Hello, my name is Esther Torky and I'm a teaching assistant at the BA. I'm going to talk about research done by myself and Dr. Lorna on how a building's facade design can affect visual and thermal comfort of the user. And the building chosen was the RAD building in Nottingham, which is also a passive house laboratory building. Building fenestrations are regarded as one of the most significant elements of a building, and if properly designed, can positively impact the well-being and health of occupants. However, with the growing trend of highly glazed facades and poor solar control, this can propagate heat gain, increase cooling load, and also negatively affect the occupant's thermal and visual comfort. Also, according to previous research, passive house buildings can be at great risk of overheating in summer due to their high insulation standards. This led us to study a passive house building in Nottingham. The building we studied was opened in 2018 and is located in the University of Nottingham. It includes laboratories, office spaces, and a central atrium. It's a steel frame structure with triple glazed windows and highly insulated and airtight. It's ventilated using an MVHR system, which aims to keep the indoor temperature from 18 to 22 degrees Celsius. This is of a POE, which was undertaken over a 3-week period, end of March, beginning of April, and it was used to evaluate the indoor environmental quality of the building. The spaces chosen were one space on the ground floor, which is an open plan office, and three other spaces, which were two laboratories and meeting room in the first floor, as you can see in the plans on the right. And these were chosen with different orientation and different uses. First, a questionnaire was given to better understand the occupants' perception of thermal and visual comfort. And then on-site data was also collected in the 4 rooms. Here from the questionnaire is the occupants that were mostly satisfied with the overall quality of the room and overall thermal condition. However, they weren't satisfied with the ability to adjust the indoor environmental conditions, since some rooms didn't have openable windows and others really had small openable windows that didn't really make a difference. On-site measurements were taken. We did an evaluation of the building to make sure it met the SIPSI and passive house standards for daylighting, which advised on a 15 to 20% window to floor ratio and a 2% daylight factor, and any more than 4% daylight factor could lead to overheating. And as you can see here from the tables on the right, that the two rooms B05 and B20, which is a meeting and a laboratory, were much higher than the recommended standards. And in the spot measurements you see later, there are several rooms that had much higher lux and luminance levels and temperatures. First, I will discuss the on-site measurements, which were taken on a sunny day at 9 a.m. and 3 p.m., and then an overcast day at 12 p.m. These measurements consist of relative humidity, temperature, and lux levels. And we have to put in mind that SIPSI recommends lux level to be between 300 and 500 lux in offices and labs. And as you can see here in an open plan office, on this 3 p.m. on a sunny day, the lux level reached 5,000, which is unacceptable. And also on that day, the temperature recorded was 27, which is also much higher than the prescribed by passive house. On this next room, which is a meeting room with also northwest facing glazing, which had a large window to floor ratio and a high daylight factor. There's significant amount of sunlight coming within the room, especially on the sunny afternoon day, and the temperature recorded in this room was 28.3 and lux levels reaching 11,000. As you can see also in this third room, the lux levels were much higher than that specified by SIPSI. On a sunny afternoon, it reached up to 12,000 lux, and there was direct sunlight entering within the room, which is also a laboratory with south and east facing glazing. Problems here appeared different at different timing than the other rooms. It was at 9 a.m. on a sunny day, and lux level reached up to 18,000. Data loggers were also used to measure temperatures indoor in the 4 rooms and externally over this 3-week period study. And as you can see in this graph and the on-site measurements taken before, temperature did exceed 25 degrees Celsius. And to put in mind that this study was taken in March and April, this shows that the building is at risk of overheating, especially in warmer months. Out from the questionnaire that the occupants located next to windows were less satisfied with thermal conditions in both summer and winter periods, and overall data collected and analyzed indicates that the building is at risk of overheating, especially during the warmer months. To conclude, since we found out that the occupants of the RAD building did experience issues with thermal and visual comfort, some things could have been done differently during the design stage, like altering the glazing ratio, adding external shading devices to mitigate solar gain, and also adding more openable windows. However, since this could not be done, since the building is already built, some things like active cooling may be needed to be considered, especially in the summer temperatures. Passive house strategies can be used to enhance energy efficiency. However, if not carefully planned, could lead to significant performance gaps and indoor conditions that are not suitable. As has been revealed in the study, more could have been done at the design stage to enhance visual and thermal comfort.